There are two types of multiplication of matrices. One is the scalar multiplication. And the other is matrix multiplication. Let's first look at the scalar multiplication of matrices. If we are given a matrix P is equal to A, B, C, D, and we want to multiply this matrix by a scalar, let the scalar be K. Then we will have Kp, which is K times the matrix, is equal to K A, B, C, D. And that is going to give us Ka, Kb, Kc, and then Kd. This simply means that the scalar will multiply each element of the matrix. Now note that this scalar that can be an integer, a fraction, or a decimal. Let's take an example. Given Q is equal to 1, 3, negative 2, 5. Then we will say that 2Q is equal to 2 times the matrix Q. And that will be equal to 2 times 1 will give us 2, 2 times 3, 6, 2 times negative 2, negative 4, and then 2 times 5 is 10. So the scalar 2 will multiply each element of the matrix. Let's take another example. Given the matrix P equal to 4, negative 6, 8, 10, and then Q equal to negative 3, 1, 4, 2. Let's find half P plus Q. And that will be equal to half P plus Q will be equal to half times the matrix P plus matrix Q. And that will be equal to half times 4 will give us 2. Half times negative 6 is negative 3. Half times 8 will give us 4. And then half times 10 will give us 5. Plus negative 3, 1, 4, 2. We have discussed the addition of matrix in our previous lesson. So 2 plus this will give you negative 1. 4 plus 4 is 8. Negative 3 plus 1 is negative 2. And then 5 plus 2 is 7. Next, we will look at the matrix multiplication, where we will multiply one matrix by another matrix. In matrix multiplication, when we are given two matrices, P equal to A, B, C, D, and then matrix Q equal to M, N, Q, R. Then P, Q, which is the addition of these two matrices, written as A, B, C, D times M, N, Q, R. How do we multiply these two matrices? We multiply the columns in the second matrix by the rows in the first matrix. And so before we multiply, we must make sure that the number of rows in the first matrix is equal to the number of columns in the second matrix. So in the first matrix, we have row 1, and then we have row 2. There are 2 rows. And in the second matrix, we have this as column 1, and then this is column 2 in our second matrix. So 2 rows in the first matrix, 2 columns in the second matrix. Now let's multiply them. Like I said, we will use the rows in the first matrix to multiply the columns in the second matrix. So let's take the first row and the first column. So row 1, column 1, and that is going to give us A times M. The first number multiplies the first number, plus C times N. The second number also multiplies the second number. Let's take the first row again by the second column. Because this is multiplying the second column, we will move to the second column. So row 1 times column 2 in the second matrix. And that is going to give us A, C, and then QR. So A will multiply Q, which is also the first one. And then C will multiply R, which is the second one. Let's go to row 2. So we are now coming to the next row. Row 2 times column 1. Row 2 times column 1. First number in row 2 will multiply the first number in column 1. And that gives us B times M. Plus the second one also multiplies the second one. D times N. Then row 2 times column 2. The first one multiplies the first one as B times Q. Plus the second also multiplies the second number in column 2 as D times R. And then we add this one to get the multiplication. Let's take an example as matrix A equal to 4, 0, 2, negative 1, and matrix B equal to 5, 2, 5, 1. Then our matrix AB, which is the multiplication of these two matrices, written as 4, 0, 2, negative 1 times 5, 2, 5, 1 will be equal to, we multiply the columns in the second matrix by the rows in the first matrix. So we have 2 columns in the second matrix, and then we have 2 rows in the first matrix. This is row 1, row 2. Let's do them one after the other. Row 1 times column 1 is going to give us the first by the first, second by second. So we have 4 times 5 plus 2 times 2. Then row 1 by column 2 is going to give us 4 times 5 plus 2 times 1. Row 2 times column 1 will give us, this is row 2, column 1, so first by first, second by second, 0 times 5 plus negative 1 times 2. Then row 2 by column 2, first by first, second by second. That also gives us 0, 5 plus negative 1, 1. And this will give us, this will be equal to, for the first column, we will have 20 plus 4. Here, 20 plus 2. Then 0 minus 2 and 0 minus 1, which will give us 24, negative 2, 22, negative 1. Let's look at the matrix B times A. When we interchange them, we will have 5, 5, 2, 1 times 4, 0, 2, negative 1. And the rule is still the same. We multiply the columns in the second matrix, column 1, column 2. by the rows in the first matrix. So row 1 by column 1 will give us 5 times 4 plus 5 times 0. Then row 1 by column 2 will give us 5 times 2 and 5 times negative 1. Row 2 by column 1 will give us 2 times 4 and then 1 times 0. Then row 2 by column 2 will give us 2 times 2, 1 times negative 1. Let's do this. We will have 20 plus 0. This is 8 plus 0. And then 10 minus 5, 4 minus 1. That is equal to 28, 5, 3. So this is how to multiply a matrix by another matrix. But you realize that our answer for A times B is different from our answer for B times A. And so since the answers are different, when we interchange A and B, we will say that matrix multiplication is not commutative, which simply means that when we interchange the various matrices, our answers will be different. Next, we will take an assignment for this lesson. Try these questions on your own. In our next lesson, we will discuss the determinants and inverse of matrices. But before you sign out, remember to subscribe to this channel and then share this video. See you in our next lesson.